Okay, welcome everybody to the Engineering Skill Sets Across Europe SEFI at Work event. So this is run by the European Society for Engineering Education. We know that there's some people who are members of SEFI joined today, but we also know there's people who are not yet member of SEFI. So welcome to you. And we have people across Europe who've joined us today. So welcome to this session. What we want to do today is we'll be doing a number of talks about engineering skills. SEFI at Work is designed to get you to have a think about engineering education during the normal working day and take some time out to listen to what the different special interest groups have been doing. My name's Neil Cooke and I'm from the University of Birmingham in the UK, and I chair this special interest group. And today we have colleagues from the UK, Italy and Germany giving talks on what they're doing in their institutions with regards to engineering skills. And we'll also have an opportunity to network too. Throughout this session, we ask you, if you've got any questions, please put them in the chat. And then the person who's speaking at the end of their presentation will be able to answer those questions in the chat. Okay, let me just move on to today's agenda then. Firstly, I just want to give a very brief, quick introduction to the Engineering Skills Special Interest Group. And then I'll pass over to Professor Kamel Hawwash, who is the SEFI former president of SEFI and also co-chairs this SIG. And he's going to talk about the position paper from 2016 of SEFI and what's happened since. We'll then have the first of our three talks on skills today. We've selected these to give a good range of talks about engineering skills and some of the current issues that we're having with them in our institutions. The first talk will be on the skill of critical thinking by Raffaella Manzini from the Università Carlo Cattiano in Luic, in Italy. The next talk will be on design, CDIO projects from Gareth Thompson in the University of Aston in the UK. Then we'll move on to transdisciplinarity, a new skill that's still emerging, and Thies Johansen from Technische Universität Berlin will be giving us a discussion on what they're doing in their institution with that particular skill. So we hope you take away from these talks some new ideas back to your own institutions and practice. There's no universal idea about how to do this introduce new engineering skills, teach them, better evidence them. So the idea of these talks is just to show you some best practice. We've got a good number of people still joining the chat, so welcome to the session. It's a great number of people, so please, if you do have questions, let me just reiterate, put them in the chat and then the speakers can answer them there. So after our main three talks, we'll be moving on to a networking opportunity, which is run by Jennifer Griffiths from University College London. So that'll enable us all to go into smaller breakout sessions where we have an exercise in engineering skills that we can have a good talk about. I'll finish with a discussion about the engineering skills survey that we ran at the SEFI conference, which is held every September. This year we ran a skills survey to ask our members about their attitudes towards skills. So we'll share some of those results with you too. So the final thing I just want to say before I pass over to the first speaker, Kamel, is what is the Engineering Skills Special Interest Group? The engineering skill set is always evolving. We've got new technologies in industries. We have this professional, non-technical skills versus traditional technical skills and the dynamic between them. So the role in our SIG is essentially to think about this and discuss ways of improving engineering education. So we have three areas of interest. We look at the inventories, what the skills are and their relative level of importance and relevance. We then look at the embedding of the skills, how we teach those specific skills in engineering programs. And then we move to think about the learner themselves and how we can better measure and evidence those skills in the learner. And our steering committee, which meets every month to have these great chats, comes from the UK, Belgium, Sweden, Germany, Italy, Ireland, Australia. If your country is not represented there or you'd like to get involved, then please drop me an email. I'll give you my email address is at the end, and we'll add you to the steering committee. Otherwise, we've got these events scheduled to run through the year where you can catch up with what we've been doing. Okay, so now I'm going to hand over to our first speaker, which is Professor Kamel Hawwash. Kamel, are you ready? And can you share your screen?
I am ready, and I am sharing my screen, I hope now.
Yes, great.
Okay, well, hello everyone, good morning, good afternoon, or evening, wherever you are, and thank you for joining us, and thank you, Neil, for the really helpful introduction. So my name is Kamel Hawwash, and I am based at the University of Birmingham. I'm involved in the SIG. I'm a former president of SEFI, and I was one of the 3 people who wrote that position paper back in 2015/16 that I would be referring to. So it's important to have a sort of a base that we start from, and that's what we tried to do in 2016. Already in the 3 points that Neil mentioned about what we are trying to do in terms of the inventory of skills, in terms of how we measure, etc., you will see that they were not present in that paper. So that's a real advance already. So you'll be able to access this paper. I'll put a link in the chat in a minute to see what we thought at the time. So it's called Developing Graduate Engineering Skills in 2016. And there was a really hot debate at the time about the skills. Which are the appropriate skills that people should be adopting? How do you then bring them into the program? But essentially, why did we do this? Universities were producing graduates that had the requisite skills, or did they? For the employment market, because we kept hearing graduates do not have the skills. But I used to argue that actually we need to be careful about that, because there are lots of people who've been through the system who are doing really well and contributing to the engineering programs. The other thing was whether universities were preparing graduates for jobs in the future that had not been created yet. And that continues to be a challenge. That was asked about regularly. We don't know what the jobs are that we need in 10 years' time. How do you prepare the graduates for them now? Whether the skills that the jobs need can be actually articulated and developed. And we also thought that this would be a baseline, the paper would be a baseline related to that. So there was a hot debate. We held a number of SEFI debates in fact, in the European Commission, and had really good discussions at the time. But it was a vibrant debate, and I'm sure it's going to continue. So some of the positions, or the position that SEFI took at the time, I'll go through these quickly, that engineering graduates should have the skills to function and thrive and be comfortable in their ability to adapt. So adaptability was one of the things that we thought was important, looking ahead and going forward. And therefore the curricula should support this by developing innovative entrepreneurial and social skills within the engineering graduate. And I have a feeling people will still say this is required. Another position was that engineering education must broaden, so ability to adapt, be broad, in addition to providing deep technological knowledge. We didn't take technological knowledge for granted, but that was the basis of all the programs. So it was safe to say, what else did they need? So we did talk then about critical thinking, oopsie daisy, creative thinking, reflective thinking, systems and synthesis capabilities, and producing novel solutions to the problems that we all face. So that was all sort of on the table. And you see the words ethics and sustainable development were important then, as they continue to be now. Higher engineering education institutions should embrace diversity, both in the students they attract and the staff they employ. Again, I believe that's continuing. There has been no big debate to say actually the situation is too diverse. Certainly in some parts of Europe, the number of females going into engineering remains low in comparison to other places where it is much closer to the sort of an equitable level. We talked about mobility. How do you, with all these skills that are developed and technological and otherwise, still ensure that a graduate in a particular country can move to another country and still feel that it's a smooth transition rather than to have to go through further assessments. And you will see familiar acronyms like EQF. There was the EURACE label as well, and the relationship between that and, say, the Washington Accord, which Europe is signed up to. Greater attention must be paid to the academic staff. Again, the development of the staff to deliver the teaching, the learning environment to create these skills was something we talked about, and that still continues. There have been 1 or 2 reports that have looked more closely at how you looking at the challenges academics face between research and teaching. How do you reward and acknowledge the transformation? Consideration should be given to how our academic staff are equally evolving and supported as educators. And then there was long life learning, which we all agree on, and SEFI has not only in ethics and sustainability, but also in lifelong learning, an important group that functions to do that. And coming to the end here, it's critical to cultivate and strengthen the relationship and exchange of know-how between industry and academia. SEFI is blessed in having a good connection with industry, and universities to varying extents have that. At the University of Birmingham, we have an industrial advisory group, and that's not unique to us. Other places have it. How do they input into looking ahead to the future, to the skills, and actually contribute also to the education itself? So we need to remain competitive. Europe as a whole needs to remain competitive, looking at the challenges of China and India and other really developing economies. I don't say developing from a low standard, but actually it's important that our own graduates have the required skills to do that. Greater attention to staff development. I think we've talked about that. Sorry, going up further. So to end, how far has engineering education progressed since 2016? I think you will hear of some examples. Certainly the issue about having a set of integrated design projects going through is important, and there will be examples discussed either today or on a future day. The next, what have we learned from the past 5 years? What are the challenges? We continue at regular SEFI conferences and certainly in the skills group to learn from each other, because sometimes one of the issues I find is really challenging is how an individual member of staff sitting in a university thinks, what do I need to do? And they think they have to invent something when there's quite an established body of knowledge now that they could refer to. And that question remains, can we predict the skills the graduates need for the unknown jobs of the future? And I think that's an ongoing challenge that we will continually face. And the debate continues. Please join us in this group and reflect back on these positions we took and see in your own environment, and certainly collectively, have we advanced since then? Thank you very much indeed.
Okay, thank you to Kamel for that very brief introduction to the position paper in 2016. I put a note in the chat so that you can look at that in a bit more detail. If you do have any other questions, then please put them in the chat, and Kamel's there to answer them for you. Okay, we're going to move on to the next presentation now, and this is on one of those skills that Kamel's just referred to, which is the critical thinking fieldwork or life skills from Raffaella Manzini. Raffaella, are you ready to share?
Yes, I hope so.
Okay, great, thank you.
Okay. Okay, here I am. I hope you can see my slides properly. I hope, can you see this slide? Yeah, okay, wonderful. Okay, thank you. I'm Raffaella Manzini, and thank you to all of you for being here with us. What I want to tell you today is just our experience in Italy, in my university, in the School of Industrial Engineering. Well, the premises are those that already Kamel and Neil are saying. There is a need for all these kind of competencies that are not traditionally intended as engineering competencies, and there is a huge and growing amount of literature which is saying all these things, and I don't want to stay here. Kamel already said so many things, and I totally agree with the position paper of 2016. But the problem, I think, is how to design engineering programs that are able to do both things. On one side, we still need a high level of vertical specialization in our programs, because there is an increasing specialization in the production of knowledge, and so our engineers are expected to be excellent and very specialized in their fields. But on the other side, we need them to have so many competencies that, such as the so-called professional or soft skills, creativity, leadership, and ability to work in groups, and everything. And these competencies are not typically vertical, but are more transversal. So our issue, our challenge as educators and teachers is how to merge these two needs that seems to be in some way conflicting each other. It seems we have to manage a trade-off, a balance between specialization, investing into vertical competencies, and investing into transversal competencies. So what we believe in LEOC with my colleagues, but we have discussed in SEFI many times, I think, about this, that probably teaching transversal competencies is not only or is not a matter of content. We cannot exactly give a set of rules or recipes for learning and using these kind of transversal competencies. And so probably an embedded or situated teaching approach could be very, very helpful, which means instead of creating modules dedicated only to the transversal competencies, trying to embed these competencies within the traditional courses, the traditional disciplines of engineers, so that students may try to build their transversal competencies already contextualized in their specific field of expertise, let's say. And this is what we are trying to do in my university, which is located in Castellanza, very close to Milano, north of Italy, a very small university, private university, founded by the local companies 30 years ago. So it is also a young university. And we are investing in terms of transversal competencies, especially in two types of competencies that Kamel mentioned before, especially critical thinking, and we put together fieldwork and life skills, referring to all those competencies that can be learned by doing things. So what we try to do is to let students develop these kind of skills, being involved into real problems, working into the real problems of companies that bring here in the university their issues, their problems. And the other set of competencies concern critical thinking, and as I said before, which we intend in terms of the learning how to analyze, synthesize, evaluate the problems with the standard and rigorous reasoning procedures, and also considering, obviously, ethical issues. So we are investing in these two transversal competencies, not only these two, but today I want to focus more on these two. And how? Well, what we are trying to do is to build some transversal path, let's say, by which students learn and use these transversal competencies within their specialization curricula, and also by using some extracurricular activities. At the end of each path, each path on these transversal competencies, we try to certify the level of competencies acquired by the students by means of the open badge tools, basically. I don't want to go too much into detail, but probably it is easy to just build these slides. So the graphic of the slides is easy. The management of this transversal path is much more complex. The learning path is built in LEUC, in our design programs, is built by giving students some specific modules within mandatory course. So there are some courses that are embedding elements concerning critical thinking and or life skills and field work. Then we offer to students some optional elective courses specifically designed to offer learning by doing and critical thinking stimulating activities. And also we have a third type of activities that are extracurricular activities, such as, for example, just to give you an example, we have created in LEUC a debate club in which we involve students in debating activities, which are obviously very useful for developing critical thinking especially. And so by means of these three types of activities, we hope our students achieve the learning outcome for each of the transversal competencies that we are investing in. And we also quantify the amount of activity that students dedicate by assigning specific ECTS to each type of activity. So at the end, if each student, we have a total amount of ECTS, which is achieved by means of modules within mandatory courses, optional courses, extracurricular activities. And obviously, it is not only a matter to sum up activities. There is the issue to create a coherent path over the years. So in the first year, obviously, we invest in something more basic, and then during the year, we try to involve students in something which is more and more complex. So I'm not sure we have defined a winning approach, not yet. We are using this kind of approach since this year, basically. And so we are really trying to embed in students in the real world in order to achieve these kind of transversal competencies. Obviously, it is very, very complex to manage and monitor activities. So now we are taking track, let's say, of what students actually do, how they select the different activities, how they perform. And so we have identified a specific management coordinator, let's say, which is one of our colleagues, it is one of the teachers involved, who is responsible for monitoring not only the teacher part, but also the student part. So how everything is going on for each specific transversal learning path. So I can bring here some consideration about our experience, even if we are at the very beginning. It is very complex to mix these two types of learning path, vertical and transversal. And there is a huge amount of coordination and management activities, which is necessary, absolutely. On the side of the colleagues, we need to be very well coordinating among teachers and also with students. And there is the very complex task of assessing the final level of skills and competencies. This is the third topic of interest of this SIG, SEFI SIG, that Neil mentioned at the beginning. So how to assess these kind of skills. And this is something that we are still struggling with. And I hope SEFI and the debates in SEFI will help me and all of us in improving this last step. So I think it's enough. And if you have any question, I'll try to answer directly by email.
Okay, thank you, Raffaella, for that talk. So we are very pressed for time. The SEFI at Work So the SEFI at Work sessions are meant to be 1 hour condensed work for all of us in our busy lives to listen to people. So we're going to move straight on to the next presentation, and that's from Gareth Thompson in the University of Aston in the UK on design. If you do have questions for Rafaela, please feel free to put them in the chat. So Gareth, are you there?
There, I'm just trying to work out how to share my screen. There we go. Okay, so hopefully you're seeing my screen.
No, we don't want that. That's me.
No, we don't want that. We'll shift over to the PowerPoint.
Thank you.
Okay, so hopefully everyone can see my PowerPoint. I'm going to present a very short talk, try and keep things on time. Projects within CDIO programs, approaches and outcomes.
Gareth, you're not sharing the correct screen.
No, what are you seeing?
You're seeing a picture of me grinning. Which is...
Let's do unshare, then go back and share the correct one, I think, Gareth. Stop share and then do it. Yeah. Oh, that's me now.
Do you want me to do the slides, Gareth?
Yeah, it might be easier. Yeah, it seems to be
Okay.
picking up the wrong window.
Okay, that's fine.
Okay, so as I said, my name is Gareth Thompson from Aston University in the UK, and I've been asked to talk about projects within CDIO programs because these are designed to address some of the issues that we've been talking about in terms of the wider skill set. So I'll perhaps run through some of our experiences. We've been part of CDIO for a number of years now, and if Neil could advance to the next slide. Okay, so CDIO stands for Conceive, Design, Implement, and Operate. Emerged following recognition that basically some of the things we're talking about here, that students were often very good at the engineering science aspects, but not necessarily good at the broader skills. Okay, again. So they brought together alumni, industry, and academics to try and identify what the key skill sets of a graduate engineer should be. And then brought that together to form CDIO, which is exemplified by CDIO syllabus and CDIO standards. The CDIO standards are 12 initially, but now it's gone up to 16, including some optional standards. And these cover things like curriculum, include sort of project-based activities, but also include things like staff development and so on. And the upshot was to try and develop a more broad-based approach with a focus on integrated and experiential learning. So certainly CDIO is not only PBL. If you speak to anyone in the CDIO community, we're quite keen to address that issue, but certainly we use project-based learning, and particularly at Aston, we use a lot of project-based learning to support our activities because we feel it gives students a broad base of not only the technical, but the group working, the interpersonal, the professional skill set. And we run projects through our first couple of years. We're fortunate to be able to be getting back on campus this year. We're in our last week or so of term. So the picture you can see on the left is students building a car that they do basically from scratch, design, build, test, first semester, first years. And it builds up a lot of skills. And we've been doing it for a number of years. So we've got some reflections on that. That we'll look at. This is just to show you the sort of structure we have. So we do an electric car, a wind turbine, a medical product, a pneumatic valve. But each of them is designed to drive forward both technical skills, but also crucially non-technical technical skills that we feel the graduate engineers should have. So you can see, as well as things like engineering drawing and design for manufacture and power generation, sensors and control, we're looking at sustainability, health and safety, ethics, IPR, and so on as well. Okay. And the next slide. So, the technical aspects tend to be assessed by a portfolio, but we also get students to do things like reflective logbooks, videos, looking at timelines and implementations to try and assess some of the non-technical skills. And what we've done, we're all familiar with doing module feedback reports and things like that we do at the end of every module, and in some ways those are useful, but it tends to focus in on the immediacy of the teaching activity, and it doesn't necessarily develop depth. So what I did a year or two back was I surveyed graduates who'd come off our programs that were now sort of 2 or 3 years up to 5 years into their career, to see how they developed and to see what elements of our courses actually made a difference to them in their working life. And we've got a strong trend towards a lot of these project-based activities, these diverse activities. So the next slide shows some comments that we got back from students. And so these are graduates that are not just sort of fresh graduates. These are ones that have been in industry for quite some time. So it's a CDIO provided a link into reality of engineering problem solving, provided a good foundation for project schedule management skills, working with teams, applied engineering. I learned a lot of the organizational and managerial skills I use today in the CDIO modules. The skills garnered in CDIO have been a constant part of my tool set as I progress through my career. The skills I developed doing group work underpin most of what I do on a daily basis. So this is the evidence that we've sort of gathered as to whether this was a good thing for us to do. The technical things have been obviously relatively easy to assess, but the feedback was often on the personal and the interpersonal and the organizational skills, and it's good to see that the students have not just valued them at the time, but have actually valued them once they're into the workplace, and that's why that's now become pretty much core to what we do in our degrees, and it's certainly become a very big positive for us in improving the employability of our students. So I think that's me done, so hopefully that will get us back on the timeline a little bit better. If anyone's got any immediate questions, then obviously you can contact me.
Okay, thank you, Gareth. Okay, so on that second presentation, I think the idea is that we want to get across the idea that we've got the traditional, non-traditional, technical, non-technical skills, and how do they get brought together? And we thought that the CDIO model was quite a nice way of articulating that, and the work being done at Aston in finding that out. So thank you, Gareth, for that presentation. There's a few things coming in through the chat, so if you're a speaker and you've got anybody asking questions, please have a look at that. But we'll now move on to transdisciplinarity. So we've looked at skills in general and critical thinking. We wanted to pick up a specific skill which we think the engineering education community has not quite grasped or understood yet, or is still evolving their understanding of. And we looked at transdisciplinarity, and we have Thies Johansson from University of Berlin to talk about that. So Thies, are you ready? Great. Thank you.
Yes, I am. Thank you very much. Oh, that was a bit fast. So basically, I'm just following up on what Kamel said and what Rafael and Gareth said as well. To me, I'm Thies. I'm speaking to you from Berlin, and today I will talk about transdisciplinarity and present an assessment method which can help to foster reflective thinking. Beforehand, however, I would like to share with you 2 observations in respect to higher education, generally, as well as engineering education in particular. On the one hand, we are expected to address what is called missions, so I have a broader perspective here. And on the other hand, we have a very rich tradition of tried and tested practice. So what does that mean? First, let me briefly say something about missions. Missions usually address issues that are very complex and far-reaching. They are, if you like, a roadmap for organizations and aim at societal impact. That makes sense, given that a lot of research and education is publicly funded, and the scientists are expected to contribute and address grand challenges. At the same time, however, we do have a practice that has always considered its impact and been concerned with users, consumers, and people. So after all, to them, it is those are the ones that then apply the solutions or products. To give you but a few examples, the best known missions probably at the time are the Sustainable Development Goals. Here they call for an urgent call of action, so they have already this transformative aspect to them. But we also have institutions that in their mission statements address societal impact. For example, the preamble of FOR Inc., which is the Faculty Days of Engineering and Computer Sciences at universities in Germany. They say we bear a high level of responsibility towards society, and my own university as well is addressing that need by saying we aim to further development of science and technology for the benefit of society. That might all be very new and sound hip, but it is something I think it's been common practice for quite some time. For example, I just brought you one example here. The economics of human system interaction, which says that this approach enhances effectiveness and efficiency, improves human well-being, user satisfaction, accessibility, and sustainability. So why then do we need a transdisciplinary approach? And I think the answer that I would like to propose is that transdisciplinarity may bridge the gap between what is expected of academia on the one hand side and what academia already does, although it does not always make that explicit. In addition, transdisciplinarity does so with academic rigor. In order to understand what transdisciplinarity actually is and why it might be beneficial, I first would like to introduce a working definition of a discipline. I believe it is fair to say that five aspects can be distinguished. First of all is a canon, so is specialized knowledge, a body of knowledge, which is taught in educational programs, can be researched with a distinct methodology, constitutes a community of peers, and is the foundation or at the foundation of institutions. If one then ventures beyond their disciplinary field, that may take on different forms. Without claim to completeness, I would like to name three of those forms: multidisciplinarity, interdisciplinarity, and transdisciplinarity. Multidisciplinarity, I think, could be argued in terms of mathematics as a sum. So it's just adding up different perspectives. Whereas interdisciplinarity in itself is a transformative process in which those involved evolve with each other. So it's like a co-evolutionary process, if you like, a co-specializing cooperative process. And transdisciplinarity is very much the same, although in the understanding I propose, you also have non-academic actors or stakeholders included. So, however, it is important to notice that those are processes and they are transformative processes at that. As I have been saying earlier, transdisciplinarity meets academic rigor. Here I've brought two examples of how these processes can be described. I cannot and will not here go into details. Let me just point out the different stages here. We have on the one hand side Jürgen Mittelstraß, who basically with his 5 stages addresses the process itself, whereas Filzmeier and Lang, who come from the field of sustainability sciences, put the problem basically in their focus. So their argument is that you could have a better understanding of a complex problem if you have different perspectives and actors or stakeholders involved. And that is important because in the end, that way you can generate socially robust solutions and knowledge. The broadening of perspective that transdisciplinarity calls for can be also, and that is, I think, a very important point for teaching, especially, a motivating factor for students. Students are commonly motivated to engage with the topic if it has a value to them and if they can expect to succeed when engaging with it. So transdisciplinarity can be a powerful means to highlight the relevance of a learning task or a topic, and thereby stimulating the intrinsic motivation, which is, as you know, the most powerful form of motivation. In addition, being confronted with perspectives from other stakeholders and seeing the effect of one's own action may very well catalyze the experience of agency and self-efficacy. Yet, as I also have mentioned before, transdisciplinarity approaches are suited to address complex problems and results in a transformative process for those involved. It is therefore, I think, paramount to reflect one's own learning process. And here I found a learning journal to be a very helpful tool. Learning journals are a coursework activity in which students reflect on how they learn rather than what they have learned. And that is especially important when you are engaged with other disciplines or when addressing effects that reach beyond your own field of work. To sum up, and in effect, I believe that the transparent integration of transdisciplinary approaches can be greatly beneficial to teaching and learning by stimulating motivation and reflection among students. And yet, as a reflective practice, that reflection is twofold because it helps us as educators, as I mentioned before as well, to reflect on our own teaching and thereby helping with formative feedback to better the teaching we do. So that is my suggestion. I've been a bit broader than before. I think the important thing here is that you can have it, as Rafaela said, embedded or integrated in your courses by just basically pointing out the effects that it has beyond what you do as a content or topic within the module.
Thank you. Thank you, Thies. So that was a really good, a very quick taster of transdisciplinarity and some of the ideas. There's a lot of information there. We're coming in on time just about, so thank you for that presentation. I'll try and sum up some of the presentations at the end of the session, but what I'd like to do now is move on rapidly to the next section, which is Jenny from UCL. Jenny, are you there?
I am, yes. I'm not going to share my screen at the moment,
right.
but I'm going to talk to everyone.
Okay, do you want me to stop sharing then?
Go on then, thanks.
Go.
So what we're going to do now is we will put you into groups of, it will probably be somewhere between 3 and 5, depending who turns up in your room, breakout groups. And we'd like you to introduce yourselves to each other. This is networking, but then have a think about, there are 3 questions. So some of you may use Mentimeter in your institutions anyway, some of you may not. It's an audience polling software. There is a link in chat. If you click on that, you will then be able to participate. In your groups, there are 3 questions already in chat. We'd like you to think about those and then answer the questions in the poll, and then we'll come back to this room. I'm only going to give you 5 minutes. It is going to feel like a very short time, and I will give you a 1-minute warning before you come back in. So thank you very much. If anyone has any problems, do just contact me in the chat. Poor Rafaela is sitting in a room on her own at the moment. I'm going to move her to another room so she's in with someone else. I realised that was incredibly quick and the rooms were incredibly unbalanced. I moved Raphael around twice because she kept being on her own.
Oh.
It's always hard to know, Jenny, don't worry.
It's like some kind of online game.
Yeah, a bit.
You've done very well to keep to the time though, so I was a bit worried at the start, but it's great.
Yeah.
We've got 10 minutes to go. It's great.
I do a lot of activities like this, and they can be anything from 5 minutes to 5 hours, depending on what time you've got. Right, I'm going to share my screen. Hello, everyone. Welcome back. I believe you can still participate through the link. It's always fun to present these whilst people are still changing things. Thank you very much. I realise that was incredibly brief and not all the rooms were that balanced. Rafaela, thank you for your patience. You got moved twice. So we've asked you to rank skills. These are skills that have kind of come up in general group discussions within the SIG, but also as skills that are often apparent in papers about skills. It's been very useful for us to discuss in the SIG already, the kind of things that people find important. And I think the most interesting thing that's come out of this today is that the technical skills are most definitely at the top above everything else. But we've got the collaborative teamwork and the critical thinking. You can have copies of these results, and obviously they're also in the recording for this session. I'm not sure if there's any surprise in terms of how difficult something is to teach and assess, and the two things do seem to be aligned. What we can see here is the little dots are people's individual marks. So some people, there is quite a bit of variation on this actually in terms of what we see here. Which means that as a group, we've actually got a lot to learn from each other. Some people are finding things more straightforward than other people. And so actually, I think this is really interesting in the SIG if we can share practice about how we're working to actually deliver these skills to students and our graduates. Finally, thank you. Do keep filling in this one. I was aware after I'd finished these slides that I had missed sustainability off the list. And that is a strong indicator that I should have put it in there. So thank you very much. I realise this has been brief. Please do keep adding to this as I realise it has been rushed, and we will share it with you soon. Thank you, Neil. I think we're about on time.
Thanks, Jenny. That was very brief, but I think really good. So I think we're coming to the last 5 minutes now. So I just want to very briefly tell you about the Engineering Skills Survey. We did a survey in at the SEFI conference in September, and you can see here, I'll go through 3 of the results that we've come in. And just like the exercise we've just done with Jenny, I just want to show you some of the things that are driving our group discussions and some of the results that we're seeing. So we asked people at SEFI conference what their ability to teach new design and technical skills are. We took these from the ASEE survey on engineering skills in 2020. So there's credit there in terms of the list, so few changes. And there wasn't any particular surprise in the ability to teach the skills. The older skills, systems thinking and problem solving, had more blue, which means we're happier with teaching them compared to some of these new emerging skills. So it's clear that as part of the SIG, we need to talk about how we can better teach these new skills, such as augmented virtual reality, digital twins, cybersecurity, and so on. So these are the technical skills that we've identified as being emerging, where we still have work to do. Then we looked at the non-technical professional skills, and the more blue you see is the more confidence that the SEFI conference delegates had in teaching that skill. The only thing I'll alert you to here is just this outlier of enterprise and entrepreneurship and business skills. So that's something as engineering educators, and we may need a little bit more attention around. But in lots of the other skills, it seems to be there is quite a high level of comfort in teaching them. The final part of the survey I'll just share with you is the hindrances that we face as educators in teaching new skills and the reasons why. And you can see these reasons down the left here and the relative levels of hindrance that we identified. The lack of time and resource was seen as curriculum too overloaded and full, which you may think is not really a surprise, but it was nice to see that verified in the survey. We've got, interestingly, people don't see student resistance as being particularly a hindrance, and likewise industry and neither. So there's just a snapshot of some of the work that the SIG's doing and some of the data that we're using to guide our discussions. So what's the time? Yeah, so we've got 3 minutes to go. So I'm just going to close this session now, and we'll keep the session open if people want to hang around for a chat afterwards. I hope you've enjoyed it today and taken away some interesting ideas back to your own institutions. The themes of the discussions, and when we were looking at the list of 5 to 10 talks we were going to do today, there's always recurrent themes in them, and I hope you've seen them today in the talks that we presented, the 3 of them. There's one of reflective learning, project work as enablers for new skills versus standalone modules. We've had 3 different countries, different institutions presenting, so there's regional differences in how we understand and structure our programs. There's that balance between technical and professional skills, and also how we progress skills through the curriculum and through different stages. And today we focused on the design skills from Gareth, transdisciplinarity through Tees, and Raffaella did the critical thinking. Our next event will be early 2022, where next year, where we'll focus on other skills, and hopefully you'll find that useful as well. In the meantime, if you want to actually join the steering group, please feel free to contact me. The final thing I just want to say is thank you very much to all the speakers today, and to SEFI headquarters, and particular Clara Luke for coordinating this Zoom session and helping us keep on time and what have you. So thanks ever such a lot, everybody. And as I said, we'll open up the session to just people if they want to hang around and talk. But now we'll close the session formally. Thank you.